One more piecewise function. So our piecewise function this time has 3 pieces. So the function y equals negative x plus 1 from the x values negative 1 to 1. Y equals 2 only where x equals 1. And y equals x squared where x is greater than 1. Okay. There are 3. They all are made of pieces. So they are all, I don't know. It's just my nickname to call them Frankenstein functions. Okay. I'm trying to find a third color here. Okay, here we go. Let's start with the first one. What does our first graph look like? Y equals negative x plus 1, so that's a linear graph. So we start at what point? Positive 1, and what direction is the slope? Down 1 over 1, so a negative slope. Okay, now we look at the domain. The domain is from negative 1 to positive 1. That's not a very big piece. Just the nose or something like that. Just kidding. Okay. So here it's less than or equal to at negative 1. No. When it's equal to, what kind of circle is it? Closed. When it's equal, it's closed. Then we go to 1, and it's not equal to. So what happens at 1? We do an open circle. And then x includes the values in between those 2 points. Well, I found that point by graphing the line originally. I know the y-intercept's at 1 and the slope is a negative 1, so I go down 1 over 1, or I can go up 1 over 1, so that point's at negative 1, 2. And then I look at the domain, and the domain says it's from negative 1 to 1. So here's where x equals negative 1, so that's where y is. And here's where x equals positive 1, and y happens to be at 0. Okay, so now I'm going to erase the extra. Alright, next. Y equals 2. What kind of equation, what kind of graph is that? It's just a horizontal line at 2, usually. But this one's even more interesting because, look, it only exists at 1 point. So the only place it exists on that line is just at the point where x equals 1. X cannot equal anything but 1. So it is a single point at x equals 2, x equals 1, and y equals 2. So we really didn't need that whole line at all. Okay, last one. Y equals x squared. That's a parabola at 0, 0. Here's kind of why I had to do the self-starter you did today. If you want to know specifically where the points are, you can always plug numbers in, right? So you plug in 0, you get 0. Plug in 1, you get 1. Plug in negative 1, you get 1. Plug in 2, you get 4. Plug in negative 2, you get positive 4. Do you see how knowing how to plug numbers in will help you make your graph nice, okay? Alright, so we have a point at 0, 0, and then 1, 1, and then 2 goes clear up to 4, like there. So you can make your parabola nice and pretty, like that. Okay, what is this one saying? X is greater than 1. I didn't draw this carefully enough because my graph shouldn't be crossing that green point at all. because the point 1, 2 is not on the graph. It's the point 1, 1 that's on the graph. Okay, so x is greater than 1. So here's where 1 is.
Do you like do that and then go this way?
Yeah. I want to ignore my phone, but I'm worried that it's my kids. It is my kids. We're almost done. I'll call them back. Because they have early day, so they're home. All right. So we should have an open circle at 1. And then because it's greater than, it's this piece. I'm not being very careful. I need graph paper to be better. Sorry, that piece is a little bit ugly. So then you can erase the rest of that parabola. And there's your function. So is it really a function? Is that going to pass the vertical line test? Yes, because these are both open circles while that one's closed. And then you move past that, you don't have the pink one anymore, just the blue one. Or if you move the other direction, you just have the pink one. And over here there's no points, but that's fine too.